This is the second video for Catia Workbench Getting Started tutorial. Sketching from a new part. In this section, you'll learn how to sketch geometry from a new part. For this you will create a simple geometry, apply constraints, analyze sketches, modify sketches, and create a pad. Creating simple geometry. To create simple geometry, you need to get familiar with a certain number of options. This task shows you how to use snap to point, use SMARTPICK, use standard construction elements, use snap to point. First, open a new part. Select Catia. Make sure that snap to point is activated. By default, this option is on. Select rectangle in the profile toolbar. Drag the cursor to define the rectangle dimensions. As you are sketching, the points are snapped to the intersection points of the grid. If this option is not activated, your sketch is not influenced by the grid points. Use SMARTPICK. The SMARTPICK tool helps you detect the constraints all along the sketch creation. For instance, here a coincidence constraint is detected during the rectangle creation with the H direction. The SMARTPICK tool is directly linked to the options that have been checked in the Tools Options dialog box. Therefore, if you do not wish to visualize the constraints detected by the SMARTPICK, then simply uncheck the appropriate options in the SMARTPICK dialog box by selecting Tools, Options, Mechanical Design, Catia, SMARTPICK. When the SMARTPICK detects a coincidence between a line and a point, this symbol is visualized in the geometry. When the SMARTPICK detects a coincidence between 2 points, this symbol is visualized in the geometry. Use the construction standard elements option. Once set to the construction mode, elements cannot be published in the 3D area. Standard elements are created by default and they can be published in the 3D area. The construction standard element option is not active by default. Create a rectangle. Select corner in the operation toolbar. Select trim all elements in the sketch tools toolbar. Select the two parallel lines one after the other. An arc of circle is displayed and you can position it as you like just by dragging the cursor. Drag the cursor to position the corner as shown. Click in the geometry to finish the corner creation. Note that the corner is created and that the two selected lines have been relimited automatically. The corner is created and as the construction standard element option is not activated, the elements of this sketch are set to the standard mode. Select the rectangle line as shown. Click the construction standard element option from the sketch tools toolbar. The selected line has been swapped to construction mode and is displayed as shown. If you want to generate a pad from this sketch, it is important to set the line in construction mode, otherwise the pad generation will not be possible. To swap it back to the standard mode, simply select it and click again the construction standard element. Note that this is only one way of creating this sketch and that you can get the same result using other commands such as profile, circle, etc. Applying constraints. You can quickly define constraints for sketch elements. You have two possibilities for this. This task shows you how to use the sketch tools toolbar. Use the constraints toolbar. Using the sketch tools toolbar. The geometrical constraint and dimensional constraints options are activated by default. Geometrical constraint displays all detected geometrical constraints. This option is only applicable when creating an object. Creating geometric constraint is possible independently of this option. Dimensional constraint only displays distance constraints when the option is activated. Geometrical constraints. Keep only geometrical constraint activated. Click Circle from the Profile toolbar. Select the corner center to define the one of the circle. Drag the cursor until circle becomes tangent to the construction line. Click in the geometry. The circle is created and the geometrical constraints have been detected. These constraints can be visualized either in the geometry area or in the specification tree. Right-click the construction line and select Delete. Select the circle and press Delete. Dimensional constraints. Keep only dimensional constraint activated. Click Circle in the Profiles toolbar. Select the corner center to define the one of the circle. Note that this symbol is displayed by the SMARTPICK as a coincidence between 2 points is detected. The Sketch Tools toolbar expands. Enter a radius value, for instance 20 mm. Press Enter. The dimensional constraint is displayed in the geometry. If you want to keep the dimensional constraints displayed, dimensional constraint in must be activated. Using the Constraints toolbar, keep your sketch open. Select the rectangle top line. Click Constraint in the Constraints toolbar. Click in the geometry to create the constraint. Select the rectangle left-hand side line. Click Constraint from the Constraints toolbar. The geometry color is swapped to the purple color, which means that it is over constraint. You can use the sketch analysis to have a diagnosis the over constraint elements. This option will be seen later on in this tutorial in the Analyzing Sketches section, which comes next. Click in the geometry to create the constraint. Right-click the radius constraint and select Delete. The constraint is deleted and the geometry is no longer over-constrained. Analyzing Sketches. This task shows how to apply an analysis on a sketch through different means such as by using the parents-children command, using the sketch solving status, using the sketch analysis. In case you did not save the previous sketch, open the getting_started.cat document. You can find the link in the description. Using the parents-children command, right-click the tangency constraint from the specification tree and select parents-children. The Parents and Children dialog box is displayed. The elements to which the selected constraint is related are shown within the dialog box. If you wish to see more details on the parents, just double-click one of the element in the dialog box. Click OK in the dialog box. Using the sketch solving status, select Circle 2. Click Constraints defined in dialog box in the Constraints toolbar. The Constraint Definition dialog box is displayed. Select the Radius Diameter option. The geometry color has turned to purple, meaning that it is over-constrained. Click OK in the dialog box. Click Sketch Solving Status from the 2D Analysis tools in the Tools toolbar. This command gives you a quick diagnosis of the geometry status. The sketch solving status dialog box is displayed and informs you of the general sketch status, whether it is under, over or ISO constrained. Meanwhile, the information given in the sketch solving status dialog box is highlighted in red in the geometry area, and the elements that are here under constrained are highlighted. Using the sketch analysis, the sketch solving status dialog box is still displayed. Click Sketch Analysis available in the sketch solving status dialog box. The sketch analysis dialog box is displayed and information is given on every element of the sketch as long as the created constraints in the diagnostic tab. Construction elements appear with a blue color in the geometry. Note that you have the possibility to sort the elements displayed in the dialog box by name, status or type by clicking the appropriate tab. Note that you can select elements from the dialog box and they will be highlighted in the geometry area. Note that you can now identify the construction elements and, for instance, swap them into standard elements. Select Hide Construction Geometries from the Sketch Analysis dialog box. All the construction elements are hidden both from the dialog box and the geometry area. Now select Hide Constraints. All the constraints are hidden both from the geometry and the dialog box. Click Close. Now select Constraint, and select Left Rectangle Line, and after V direction. Then select Constraint again, and select Bottom Rectangle Line, and after H direction. You can see the geometry color turns to green, meaning the whole geometry is now ISO constrained. Modifying sketches. This task shows you how to use undo, redo or delete elements. In case you did not save the previous sketch, open the getting_started cat part document. Using the undo, redo command, click Circle in the Profile toolbar. Position the cursor until the SMARTPICK detects a constraint as shown. Click in the geometry and drag the cursor to create the circle. Note that when SMARTPICK cursor crosses a fictitious horizontal line that would go through point, SMARTPICK snaps in order to remain horizontal to this point. In this case, no constraint is created. The circle is created as shown. If you are not satisfied with your sketch, click Undo in the standard toolbar to go back in your sketch history creation. Conversely, if you have been too far in your sketch history creation, click Redo from the standard toolbar to go ahead in your sketch creation. Deleting elements. Double-click Quick Trim to make it permanent from the Limitations sub-toolbar in the Operation toolbar. Select the line within the circle. A warning is displayed informing you that dimensional constraints cannot be deleted. Click Yes in the dialog box. Select the circle from the part outside the rectangle. The selected line and a circle part are deleted from the geometry. Note that the place where you select their geometry to be deleted is important, as it is the exact part that will be deleted. You can also use a contextual menu to delete elements. Creating a pad. This task shows you how to exit the sketch or workbench in order to create a pad. Select Exit Workbench in the Workbench toolbar. Your sketch is displayed in the Part Design workbench. Click Pad. The pad definition dialog box is displayed and a pad preview is shown in the geometry area. Enter 25 in the length field. Click OK to validate the pad creation. The pad is created as shown. You can use Sketch to edit a sketch from the pad definition dialog box.